Hello, I'm Dr. Collins, and in this particular video we will have a brief introduction to statistics. It is important to emphasize that understanding statistics is not just for the statisticians. As a good healthcare professional, you need to be able to stay up to date with all the new information and research relevant to your field. In fact, you might be conducting some research or audits yourself. Having a basic understanding of statistics will allow you to decide what is good research, which studies are worthy of our attention for our patients' care, and how you can analyze your own data for your own research. But fear not, we'll break down statistics such that not only will it be super easy to understand, but we'll also cover why it is important to understand each particular concept in relation to research and analysis purposes. So, in the first part of this video, we will have a quick look at some bread and butter terminology for statistics, which are mean, median, and mode. And in the second half, we will explore the utility of these terms. Okay, so let's say we have got the following completely made up 16 numbers, which means that our sample size, which is also sometimes referred to as the N of a study, is 16. So you can think of it as 16 observations or readings or measurements to work with. For the purposes of simplicity, I've picked up an easy set of values to work with. But remember, in real life research, these numbers can be anything. So let's have a look at what we've got here. We have got a 1, 2 2s, 3 3s, 4 4s, 3 5s, 2 6s, and a 7. Mean is basically the average of these numbers. In other words, you line up all your numbers and add them up and divide it by our sample size, which in this case is 16. So go ahead, pause the video and add it all up and divide the total number by 16. Have we all got 4? Excellent, that's our mean. Easy enough? Let's move on to the median, which is basically the number right in the middle of our data set. To be able to work out the median, it is best to list our data set in ascending order. However, there is a little trick here. Determining the median is a lot easier if you have an odd total number of values, because you simply look at the value right in the middle of the data set. So if we had this set of numbers instead, I've just removed one of the 4s. We've got a sample size of 15 instead. And the number right in the middle of this set, 4, is your median value. Now, let's go back to our original set. We've got 16 numbers, which is an even number. We'll also learn how to determine the median when you have an even number of values. So the median number in this case is the average or the mean of the two middle numbers. So you've got 4 and 4. So you add them up, 8, and divide by 2 is still 4. And that's our median. Last but not least, we've got the mode, which is basically the number that appears the most times, the most frequently in our data set. If you look at this table, it's a little bit easier to see. We have number 4 appearing 4 times. All the other numbers are appearing 3 or less times. So as the most commonly appearing number in our data set, our mode is also 4. Now that we know what the mean, median, and the mode are and how to calculate them, it is time to answer, why do we care? What does this all mean? So here we go. When you do a study and obtain a set of numerical data based on whatever you measured, observed, or counted, you need to understand the nature, or in other words, the distribution of your data set. The mean, the median, and the mode of your data gives you the ability to understand what kind of data set you've got. I'm sure you're now wondering why it matters to know what kind of distribution your data has. It matters greatly because based on your distribution, you will then choose a type of test. For example, you might have heard of the student t-test, ANOVA, or chi-square in order to analyze your data. And that analysis will in return tell you whether what you observed in your study is statistically significant or it was just an observation that happened by chance. Statistical significance, which you might have heard of as the p-value of the studies, lies in the heart of all experiments to make sense of your data. Can I rely on this data, this specific pattern observed, this deduction we are making? Or was this just a random observation and the next time this experiment is repeated, it may or may not observe again? This is all getting a bit theoretical. So to make sense of things, let's plot our data on a graph. So our measurements are on the x-axis and their frequency on the y-axis. We get a graph like this. 1 1, 2 2s, 3 threes, and so on. Then we need to see if our data resemble a symmetrical bell. So we connect our data together, and if it does resemble a symmetrical bell shape, and in this case it certainly does, it is said to have a normal distribution. And this data therefore can be analyzed using parametric tests such as the student's t-test. If your data doesn't have a normal distribution, in other words, if it didn't resemble a symmetrical bell shape when you plotted it, then you would have to use a non-parametric test such as chi-squared to analyze your data. Remember, if you don't choose the correct type of statistical analysis based on the distribution of your data, then your analysis is unreliable. The important thing to note here is that in normally distributed data, the mean, the mode, and the median of the data are the same or about the same. So remember, in our previous slide, we have calculated our mean, mode, and the median, and they were all equal to 4, which means that even without plotting our data on a graph and drawing the bell shape over it, we knew that our data is normally distributed. I'd like to make a side note here that in real life, when you do an experiment, you can either use this method of deducing your own distribution, or you can use pre-validated normality test, for example, the Shapiro-Wilk test on an online calculator, where you just put in your data set and it does this assessment for you. And in larger data sets, this is certainly more practical. However, it is still very important to understand how your data is distributed, which will guide you on which statistical test to use for your analysis. Or when you're reading other studies, you can double check that they are doing reliable statistics. To summarize, in this short video on the very basics of statistics, we have learned that the mean, mode, and the median are the bread and butter terminology to describe the distribution of a data set. And we don't do these calculations just so that we get a good workout of our brains, but rather it also gives us a good understanding as to how our data is distributed. If your mean, median, and mode are the same or about the same, that means your dataset is normally distributed. And if you were to plot it on a graph, it would have a symmetrical bell-shaped appearance, in which case you could use parametric tests to analyze your data. If not, in other words, if your data isn't normally distributed, you would need to consider non-parametric tests for your analysis to be able to obtain reliable statistical deductions. Obviously, we will need to explore these tests in a lot more detail and consider other things whilst choosing the statistical test you will use to analyze your data with, but I'm afraid that will have to be the task of another video. Thanks for watching. If you like this video, please subscribe to support more videos to be made. For more videos, you can visit the following website. Good luck!